Welcome back to this course on fundamentals of data science. And now recently we are discussing about machine learning methods. And today we are going to talk about one of the popular machine learning methods. It's called the classification methods. And we are going to see some of the common classification methods with some simple examples. So that's going to be our objective for today. We are going to talk about what is a classifier and how classifications are done and how they can be represented as a machine learning methods. We will also talk about types of classification, and in general we are going to focus on one type. It's called a sentiment classification or sentiment classifier. Before we move on to the actual topic of classifier, let us discuss few points on regression. Well, we already discussed what a regression is. You know what is a regression. A regression model can predict a continuous value such as height, weight, so on and so forth. Even regressions are used to predict stock prices if you have enough data, as well as it can be used to predict other aspects like house price. These are some of the examples of regression, which means that regression is also a part of machine learning. So that's one of the basic machine learning method, because you can predict few things just with the regression model. Well, we have already seen what a regression is, but now we are going to shift on to the next topic, which is the classification. As we move ahead with this topic of classification, we are going to see how the regression is also related in somehow to classify things. So we know that regression can predict certain features. So such as if you have a sound signal that contains human voice, based on probability, you can predict certain regression models. Just by using certain regression models, you can actually predict whether this sound is a human voice or not, just by looking at certain aspects. Even the classifier does the same thing. It uses certain decision rules to classify. So one way of looking at it is prediction, the other way of looking at it is classification. So that's how it differs actually. And in the end, we also talked about what is a logistic regression in another lecture, where it actually classifies two things: pass and fail in an exam, for example. That's a simple binary classification. So we have to understand the difference between classification and regression. We know that regression, the output variable takes continuous value, whereas classification, the output is always a class label. You are going to label, just provide a label as an output. And regression means to predict the output value using training data, whereas classification means to group the output value into a certain class with its label. So that's the key difference that you have. Let's move into this classification. We are going to see some examples of how this is done. So this here we see a classical example of a classifier. As you can see, when you have an email coming in, we can use a simple machine learning model. In this case, we can use a simple classifier which can classify this input email as a spam or not spam. So it's again a simple classifier, which means that it's like a binary classification, just two options you have, which means that you have to set a simple threshold values to classify into a spam or not spam. That's the basic idea behind this particular classifier. Let's go in details with some types of classification. There are, in fact, I would say that there are thousands of types of classifier. You can talk about all different kinds of classifiers. Here is some examples like sentiment classifier. So this classifier determines if a text is a positive or a negative. When I say text is positive or negative, just looking at a sentence which contains different words. So these are the text. When looking at a sentence, maybe a message in your tweet or Facebook or in a blog post or a product review, or just looking at a website and browsing through all the words in those sentences, does these words implies a positive or negative thought? In fact, we are going to see an example of sentiment classifier in today's lecture, so I will stop it there for that sentiment classifier definition. Then comes the topic classifier. So as I mentioned, if you are looking at a website and if you want to check in for all the words that are in that website, you can automatically classify either this website talks about sports, it talks about politics, it talks about science and technology, or it talks about any other similar features like recreations, art, business, computer games, health, home. Yeah, that's a topic classifier. You can also do that for several ebooks you have, and then you want to classify whether a certain books belong to data science, certain book belongs to, say, business, art, so on. Then comes the image classification. You can classify just with an image. You can see whether dog or a cat or man or a woman. All different types of classification can be done. Maybe even people do classification to classify whether this car is an Audi or BMW or Hyundai or Toyota. Yeah, those classifications are also being done. Then comes the mood classification, the state of mind of a writer, whether he is upset or happy. Say you see text messages. From these text messages, can you identify the mood of the sender or the mood of the writer? Or you have the tweet messages, and those messages, looking at those messages, can you classify? Well, people are doing that. Classification can be done just by looking at what a writer writes about his feeling. Gender classification. This classifier tries to figure out if the text is written by a male or female. That's interesting, isn't it? Or is it written by a young people, a teenager, or a old person? That's another interesting classifier. Yes, thousands of classifiers are already out there. And today we are going to discuss with the same line of thought. We are going to use text information, and we are going to assume a few informations based on this text, and then we are going to see how we can extract a certain sentiment from this text for reviewing the movie. So this is a kind of a sentiment classifier. So we are going to use the same principle that is used for product reviews. So this movie review, we are going to discuss about the Ready Player One in this example. Yes, as you can see, the Ready Player One movie. So you want to see its rating. You want to know, does people recommend you to see this movie or not? Maybe you want to know whether this movie has a positive or negative reviews. Yes, maybe you can also think about if you want to take your children to this movie, whether it is violent or any other immoral things are highlighted in that movie. Well, let's look at this example here. Here it is. This is a sample review of the movie given to us. So there are, in this sample reviews, we have 3 reviews I have taken as a sample for this movie Ready Player One, and the title of this sample review is a very cool and very exciting movie, but suitable for teens and up, which has both positive as well as the negative aspect, right? He says very cool and very exciting movie, which is good for teens. That's what he suggested. He is not recommending this for young people. Yes, this is a super duper cool, exciting movie. Again, that is a positive words, sentiments. The next one, stellar science fiction adventure with incredible effect, character and story. That is in fact is very positive thought about this movie. Then there are some more aspects. We can see what this particular author talks about. You can see here it says the characters are good and played well. I loved the story. So I thought everything about the movie was great. So that's again a very positive aspect. So he also mentioned few other points. He says that the movie has video game style violence and extremely over the top action and battle sense, which means it has a little bit of violence related to it in the video game style. There is few more informations where you can see there is a scene with a nude woman, but the angle doesn't reveal much. Yes, he is just giving a word of caution for what you can look forward. Finally, he says, I highly recommend this movie. So this is about the second review. Let's talk about the last one. So here it says, my husband I loved the book which was released, the movie is based on this book it seems, and here the writer of this comment says that if you loved the book, don't waste your money or time on this movie. If you haven't read the book, you will probably think it's great. We are very disappointed, which means that those people who read the movie, read the book, were disappointed on seeing this movie. At least from this one particular review we can see. Okay, what we have observed here is we have various reviews given to this movie, and based on that, can we identify or can we recommend this movie or not for another person, just by means of analyzing the sentiment from the reviews. It's not about recommendation system, which is quite different. It's just about classifying a movie as having positive reviews or negative reviews. Yes, this is how we are going to do that. So the sentiment classification, is it positive sentiment or the negative sentiment? So we have to take all the reviews into account and try to break them up into sentence. So each review composed of multiple sentence and multiple sentence. These sentences consist of multiple words. So based on that, you can actually classify either these words are having positive thought or negative thought. Just for example, if you talk about like super duper cool, exciting movie, these two are definitely having positive thoughts. So this sentence, this particular sentence, super duper cool and exciting movie, has positive thought. That's a simple classification that we see here. So that's the thought. You take the sentence from the review and try to break them. You have the whole reviews, you are going to break the whole reviews into a sentence and take the sentence from the reviews. Also look at the context as well as the words in the review. In some sense, if you want to do a thorough classification, you may also have to have an NLP based system to identify the context in which it is said. So you have to build a classifier model. In other words, you have to try to understand and build a classifier algorithm or a model, and finally this model should give you a positive or negative review as its output. So that is the classifier we talk about here. Input features are given to it, classifier classifies the actual output, and the label, in our case the label is positive or negative. So we will discuss in detail. So here is the thought. So you have the sentence from the review is given as the input, and you have list of words which have positive thoughts like fantastic, super, great, awesome, good, amazing, incredible. For example, these are positive words, and negative words like disappointed, horrible, bad, terrible, disgusting, waste. So these are a list of positive and negative words we have there, and when you see the input sentence from the review, you are trying to count the positive words. You are going to count the positive words which represent positive thoughts, and you are also going to count the words which are going to have negative thoughts in the sentence that is given as the input. So idea is very simple. If the number of positive words is greater than the number of negative words, then the output is positive, else the output is negative, right? So if the number of positive words is greater than the number of negative words, your review output is positive review, that is your label output, else it is going to be negative review output. So this is a basic algorithms. Well, as we said, it's a basic algorithm. Maybe basic algorithm always has certain problem to it. So how do we get the list of positive and negative words? That's another question, right? So you may have to think about this. Does all words has the same way it is represented? For example, you can see here there is difference between good and great. Both are having positive thought, but we know that great has more weights than good. And again, if you think about good, which is positive, but when you have not good, this is a negative. So this issue has to be addressed by the classifier. So here is where we have this entire classifier given here. So your actual threshold has been set by the classifier. So this whole classifier has to address this need of actually performing degree of sentiment based on the words and its thought, as well as single word is just not enough to represent the whole thought as positive or negative. So you have to be more elaborate these features. Maybe then we can in fact improve this structure. For example, you are trying to give some weights, like you are giving these weights, for example, for this linear classifier, and based on that we are going to check in on how this can be done. So you are giving good 1, great 1.5, awesome 2.5, bad minus 1.0, terrible minus 2.1. Those points are given, and some words like general words like movie, reviews, comments, for these words you don't give any points. Now we are going to shift in those things, like you can see here the same idea. The movie was incredible, the action was awesome, but the storyline is terrible. So if this is given to us, we know that some thoughts are given, like we can see if suppose incredible has 2.0, if awesome has 2.5, and if terrible has minus 2.8. So the basic thought is 2 plus 2.5. Then you have to say this is greater than, in fact, or if you, even if you add this with minus 2.8, you are getting a positive value. So this is basic classifier that you have here. So with this basic classifier we can actually make this sentence more appealing. So right now we have these words and weights given to us. Initially we just had positive and negative words, but right now we are going to have all the words and their weights are given. As you can see here, the words and the weights are given, and then you are taking the sentence from the review, and now our classifier is taking a score, and this score is going to count the weights of the words in the sentence. It's not about counting the positive and negative words, we are going to count the weights from the given sentence. If the sum of weights is positive, then we are going to say it is a positive review. In other words, if the score is more than 0, you are going for a positive review as your output, else you are going for a negative review as an output. So that's very simple, as we can see here. This is a very simple classifier. We have classified it based on the input sentence, but we have improved it by giving weights to the words. So based on that, you can actually give the training for the entire system. Since you have list of review sentences, and you can use these sentences as an input to the system. So you have this data, you are giving the input, and you can in fact split the data into training set as well as the test set. Say for example you have 1000 sentence. So 1000 sentences are there in the data, that's in the data, and you are going to split up 1000 into, say for example, you are going to split 800 sentence, or split into the training set, where you are actually training, where the classifier learns the whole process, and maybe you are going to use say 200, remaining 200 sentence for testing. So this learning is done based on the word and weight. Based on that, your training is done, and once the training is done for those 800 sentences, now we are going to use this 200 sentences and going to evaluate. Yes, these weights are going to be used to score every element there. Let's see, here is a test example. So we have the sentence, say movie was great, which is positive, we know that, and the learned classifier put it as positive. So here is the output, which also you get positive, which means that is your correct answer. Then now you have movie was okay. Well, movie was okay. Sometimes okay is just not really revealing the positive thought. So, but still your classifier is classifying it as positive, which is a mistake. So we are one incorrect. We got one incorrect. So likewise, you are going to do for every sentence. For every sentence, you are going to count the number of correct classification, number of incorrect classification. Once you're done with all these correct and incorrect classification, you can see what is the accuracy of the system. That's where the classification error and accuracy comes in. So the error is number of incorrect divided by total number of sentences. So how many incorrect you got from the total number of sentences? So the best possible value is 0. You got 0 incorrect. And accuracy is termed as number of incorrect divided by the total number of correct divided by total number of sentence. So this one you want to have positive. Just for example, if the total number of sentences are say 1000 and number of incorrect is say 100, then it's almost the 10% of this is having error. On the other hand, if 1000 among 1000 sentences, if 1000 sentences we got the correct value, then your accuracy is 100%. But this again, if you want to talk about the same thought, here again if you want to use the same number here, then you are going to look at the number of correct would be 900 divided by 1000, which means that your accuracy is 90%. So in this case the accuracy is 100%. In this case the error is 10%. So that's the thought. And one final thing with regards to classification, error and accuracy, there is something that we need to understand as far as classifiers are concerned. Is the classifier with 95% good? Well, it depends. It depends on whether it is good or not. Just for example, consider you have a set of data which has dogs and cats, and among them, say for example, you have 1000 pets, in which among 1000 say you have 95 dogs and 5 cats. So this is your data. So in this data, when you input it, suppose your classifier just automatically assign the output label as dog for every pet that you are giving in. So this is a pet data set. So if it automatically gives everything as dog, whatever you give as the input, the output is dog, then your accuracy is 95%, right? Just give an input and output is always the class of dog. Does it shows that this classifier is a good classifier? Definitely not. So this is one of the critical thing that we have to examine. So that's where the actual evaluation process and cross validation process is needed as far as classification is concerned. So that's where another topic of this confusion matrix comes in, and I would like to discuss about this confusion matrix for various machine learning methods. We use certain confusion matrix to understand actually what is happening, and we will be talking about in detail in other lecture as well. But for the time being, we are going to see what is this confusion matrix. Basically, it is a matrix, or in other words, a error matrix, which has a simple table. And this table visualization allows us to understand actually how the algorithm is performing. Just like you can see here, you have true positive, true negative, false positive, false negative. And moreover, you can look at this A plus D is good prediction, which means whenever your prediction, your classification or prediction is true positive, which is truly positive. For example, in case of a cat and dog, if it is the input is dog and the output is also dog, that is true positive. And if the input is cat and the output is also cat, that is true negative. Whereas on the other hand, if the input is dog and the output is cat, that is false positive. And if the input is dog, or if you have the output as cat, again you may think about that is a bad prediction. B and C are the bad prediction, where you may have false negative. For example, if your input is cat and the output is dog, you have the scenario where you have a bad prediction. So you may have to understand how this is actually happening, what is the bad prediction is all about. Sometimes you may not be aware of how this is useful to understand, because as far as some disease is concerned, if you want to evaluate a system and if you want to know somebody is having a disease or not, your accuracy matters a lot. If somebody does not have a disease and is being classified as he is having a disease, then he has to be treated. So medicine is given to him, which is also harmful. Sometimes he does not have a disease and he has been classified as having a disease. Sometimes he have a disease, but he has been classified as he is not having a disease. Sometimes it is a dog, but you classify it as cat. Sometimes it is the other way around. So this might happen. So it seems for cat and dogs it's not a big deal, but for disease, if a person has a disease and if he has been classified as not having a disease, then that is a big issue. So that's actually very big impact on a person. At the same time, a person is not having, in fact he is having a disease, he's been classified as not having a disease is one aspect. On the other hand, if he does not have a disease, a person does not have a disease but he has been classified as having a disease. So this can also happen to a person. So that's where we have this system to understand the actual thing with regards to confusion matrix. So if a classification system is trained to distinguish between cats and dogs, a confusion matrix as such here can summarize the results of testing algorithm for further inspection. So let's assume that we have 13 samples. You have 8 cats and 5 dogs, and you have the resultant confusion matrix that looks like here, right? You have the class of 5 dogs, and you can see there are 8, or in fact there are 8 cats actually. These are 3 plus 5, and you have 2 plus 3, which is 5. So this is the actual thing that you have in hand. So in fact I want to revise this so you can understand what is happening. I think we had a wrong values given. Okay, so you have 8 cats and 5 dogs. Let's look at this confusion matrix. So in this confusion matrix, there are 8 actual cats. You can see the system predicted that 3 were dogs, right? Among the actual cats, the system has predicted 3 as dogs, and of 5 dogs it has predicted 2 as cats among the 5 dogs. So all correct predictions are located, as you can see, in the diagonal of the table, highlighted in bold in this case. So this is a correct prediction, and dog, it is a correct prediction. So it is easy to visualize and inspect the table for prediction error in this case. So that's one of the advantage of having a confusion matrix. So just get used to it so that it can be used for evaluation process. So that's all we have for today's class, in which we discussed about what a classifier is, types of classification, and how classification is done in machine learning process. And we saw an example of sentiment analysis, in fact sentiment classifier, using a movie review, and we use the sentence to see whether this movie has positive reviews or negative reviews. That's in for today's class, and in next session we are going to discuss about the k nearest neighbor method as well as the support vector machine. I am looking forward to see you there. Until then, goodbye.